Thank you very much. Good morning, everyone. Welcome also from my side. Exactly, I'm Marco Buoni, Real Alternatives Ambassador and Area President, the European Association of RAC Refrigeration Service Technicians. Today, we'd like to give you just a very brief note of what is Real Alternatives. And you will see in the next hour a lot of details about Real Alternatives, and also short training from extracted from the training course. Real Alternatives is a blended learning, which means you can learn about low GWP refrigerant, alternative refrigerants online or in classroom. And the refrigerants are the flammables, HFC, HFOs, HFC blends, hydrocarbons, CO2, ammonia, low GWP refrigerants. We have 9 modules with different learning materials, in particular about safety. We have free learning material available for download. We have multilingual. Today is an example. We have translation in several languages to reach our technicians across many countries. And we have exactly 600 registrations also for this reason. And we have 20 countries joining Real Alternatives project. We have been, from the beginning, funded by European Union and supported by European Commission and UNEP, and presented in several different events. In light of F-gas regulation review, it's very important to have training material, not just learning, but also, as I said, practical. For example, we have licensed training providers in each country where you can do best practices in full equipped laboratories. You will see many pictures, for example, from Spain, from Armenia, from Romania, from Czech Republic, from Slovakia, and also from Brazing in Poland, about training. And also we do theory in classroom or remote, now that we are all remote. And also we do certification, which is very important. On top of F-gas regulation, or on top of your national regulation, to have a certification about alternative refrigerants. And we hope that this will be implemented in the revision of gas regulation. This is a very important topic for the next revision. We are moving to alternative refrigerant, low GWP refrigerant, and so we also need to move to skill up our technicians that are going to use these new refrigerants that need special skills about flammability, toxicity, and high pressures. And we already certified more than 2,000 technicians. Our sector is dynamic. Our sector is very, very enthusiastic. Our teachers are very enthusiastic, and it's changing quite quickly, our sector. So we need as well to change quick. And our sector, most of all, is essential. We saw it in the last 2 years. 2 points about our agenda. In the first hour, we will have introductions about what we do in Real Alternatives, the importance of training and certification by Didier Coulomb, greetings by our stakeholders, our training centers, an example of one of the trainees that did in Brazing our training, evolution from Real Alternatives, what was the path of a learning experience as well from Miriam Woodway about, he was going to show you how to assess to enter our training courses. And then the short training by Marino Bassi of Centro Studi Galileo and by Kivanch of SOSİAD. And then a wrap up at the end. Now, I don't want to take more time. I would like to give the floor to the director of IAR, Didier Coulomb. Thank you, Didier, for being with us today. You can unmute yourself, and we can have your speech about the importance of training and certification. Please unmute. You're still in mute. Thank you, Didier. Nice to see you virtually here today.
Thank you, Marco. So, good morning, everyone, or perhaps good evening for certain people, but generally good morning. I would like to present you the importance of training and certification. Next. Well, first, with a short introduction about the International Institute of Refrigeration, our actions regarding training and certification, but insisting on 2 aspects. First, the increasing importance of refrigeration, and secondly, the need for qualified technicians. And of course, as a conclusion, the need of training and certification, and the need of this webinar. Next. The IIR, International Institute of Refrigeration, was founded in 1908. It is an independent, intergovernmental science and technology-based organization, and its mission is to disseminate worldwide knowledge on all refrigeration technologies and uses with the goal of a refrigeration for sustainable development. Next. Well, key domains of our activities include food quality and safety from farm to consumer, comfort in homes and commercial buildings, healthcare products and services, low temperature and liquefied gas technologies, energy efficiency, and the safe use of non-ozone depleting and low global warming refrigerants. Since the beginning, just of course, before we had this Relativity for Life initiative. And all our activities are linked with the Sustainable Development Goals of the United Nations. We have an international network with 59 member countries, almost 1,000 corporate and private members, and more than 300 experts with coordination and actions with all the various organizations. You have some examples just at the bottom of that slide. What do? We have our goal, of course, is to have an efficient information network adapted to your needs. We have a FreeDoc database with almost 110,000 references. We have the International Journal of Refrigeration, which is the peer-reviewed journal, which is the reference in that field. We publish guides, courses, informatory notes for decision makers. We have professional directories. We have a newsletter, organized conferences all over the world. We have working groups, research and development projects. And if you can see on our website, all our activities, you will see that refrigerants are clearly one of the most important subjects of our conferences, of our guides, of our informatory notes. Next. First, the increasing importance of refrigeration. Of course, refrigeration is necessary as the cold chain for food. Refrigeration capacities, for instance, can be 10 times lower in developing countries than in developed ones, and the population is growing. So it is a problem of food security, it's a problem of health. And regarding health, it is not only the problem for food, but also health products and services such as vaccines and all the problems we had as logistic problems regarding vaccines for the COVID. 1 in 2 medicines on the market is now heat sensitive. So you need the cold chain for food and health products. Air conditioning global energy needs for space cooling are set to triple by 2050, especially in developing countries, but also in countries where it is less developed, for instance, in Central or North Europe. It will become a necessity all over the world, of course, also for vehicle air conditioning and so on. New technologies need constant temperatures, and thus you need refrigeration. Information technologies, databases, data centers, biotechnologies, CPS technologies, for instance. Heat pumps have a unique role in the energy system of the future. We see already that in Europe, in Eastern Asia, in North America. Gas liquefaction, I mentioned hydrogen and CO2 in the slide, but of course, you now also are certainly aware of the role of liquefied natural gas regarding the current events in Europe. And cryogenics in hospitals, for instance, you need refrigeration for all these activities, which are absolutely necessary. And thus, we need more people in the industry and in maintenance services. Next. We, in addition, need more qualified technicians. The refrigeration accounts for 7.8% of global greenhouse gas emissions. It is not negligible. Most of that, 63%, is due to the production of electrical energy, and refrigeration accounts for 20% of the global energy consumption. And these figures are increasing. We thus need better energy efficiency and more complex systems that save energy and use renewables. Of course, it is not directly linked, but it is clearly indirectly linked with the message I would like to now give you regarding refrigerants, because of course we need, in implementing this system, the refrigeration system, we need to take into account the issue of energy consumption. 37% of these global greenhouse gas emissions due to the refrigeration sector is due to fluorocarbons, CFCs, HCFCs, HFCs. We need to use lower global warming potential refrigerants and, where possible, very low GWP refrigerants, including natural refrigerants, because of the Kigali Amendment. Of course, for certain countries who have more time to do it, to phase down HFCs and to phase out HCFCs, but we need to be prepared for the very near future. Low global warming potential refrigerants are either flammable, mildly flammable, toxic, or high pressure, and cannot be installed and used similarly to the previous refrigerant equipment. And thus, we need more qualified people. And certification of technicians is even mandatory, such in the EU with the F-gas regulation. Next. So as a conclusion, training and certification are required. Relatives for Life is a project funded by the European Commission, and the IA was a member of the consortium, as we are in other projects with the European Commission, but also with the United Nations agencies and programs.
Çok özür dilerim, internet problemi nedeniyle koptum.
Course materials have been developed. They have been already translated in various natural languages: Croatian, Czech, Dutch, English, Finnish, French, German, Italian, Polish, Portuguese, Romanian, Russian, Slovenian, Spanish, Turkish, Estonian, Greek, and 20 national associations can now implement them according to their national context. And I hope that we have next time more languages, more national associations involved. Thank you.
Thank you, Didier. This was very good introduction for the Real Alternatives project. I ask everyone to put the questions in the question box, please. And now I pass the word to the first round of stakeholders, training centers, that will give us a good example of what we do. Blanca, I ask you to share your screen, please. Blanca Gomez from CNI Spain. We can see you very well. Maybe we can hear you as well. So I will ask everyone to put questions in the question box, even for Didier. If there is question, please, we will ask later to Didier. We will have some question and answer section at the end of his stakeholders and experience delivering training across Europe section. In Spain, you have to know, I don't see the full screen yet, Blanca. If you can put it full screen, please. And if you can try to speak as well, Blanca, just to try to check that you are.
Yeah, okay.
Yeah, we can see you. Yeah, we can hear you.
Yeah, I think I have. Now some problem to put a full screen. I'm very sorry.
Okay, but we can see your screen. I think nobody's going to be mad about you if you keep it like that anyway. We can read it anyway, Blanca. You can just change slide on your left. I don't think everybody. Oh, yes, this is perfect now, Blanca. Magic. Only one thing I want to say about you. Spain is a success story. We had in Spain the Real Alternatives project and schemes mandatory for the country. So it is available for the mandatory certification that the technician need to have to work on alternative refrigerants. So thank you, Blanca, for being on the forward for Europe. We hope to have similar schemes available in the rest of Europe. Thank you, Blanca. Your turn.
Okay, thank you. Thank you to all, and thank you for inviting me to participate in this very interesting conference. I will talk a little bit about our sector in Spain. Spain, as you can see in the map, is a big country in Europe with almost more than 500,000 inhabitants and 127 certified professionals and 20,000 companies working in the refrigeration area, which is, this is an estimation. Our confederation was founded almost 50 years ago, in 1973. We have 16 associations. We are contractors companies, installation companies, and most of our members are companies working in the HVAC refrigeration area. So we concentrate our activity in refrigeration, air conditioning mostly. When the European regulation in 2014, the F-gas regulation was approved, we realized very quick that 15 years could seem a very long term to adapt, but it wasn't because a new area was starting and we needed a certified good professionals, very good qualified for the new area of new gases with new systems, and we had to start thinking of training. That's why we took contact with the Real Alternatives platform. Realized was a very good training material in, and we informed our government, our ministry, environment ministry, about this platform, because they were working on the transposition of the European regulation to our legal map. So what they did was to translate with us the full platform. And in 2017, when the F-gas regulation, the Spanish F-gas regulation was implemented, they regulated something very important, which was an extra 6 hours training in alternative refrigerants, obligatory, mandatory for all professionals. And they had a period of 4 years until February 2021 to adapt, to make this mandatory training. And they validated the Real Alternative certification as valid to prove this training. Of course, the platform, the Real Alternative content was much more wide than just 6 hours, but they did it, and was very important to make it valid to prove this mandatory training. In 2018, we became national lead of Real Alternatives in Spain. And up to date, we have 5 homologated training centers. We have almost 1,000 certified individuals and over 2,000 users in the platform. What are our aim in the near future? Now, 2021 has passed, so most professionals are already certified. But for us, it's very important to have really good trained professionals for new gases which are entering the market every day. So we'd like to homologate new training centers to promote practical training, which is very important, and to spread trained professionals. Because most professionals, our feeling is that they think they don't need that. They think they know all, and this is not real. It's always good to have more training because new gases are flammable, and they need new safety characteristics, and they need to know more about them. So new good practices are very important for them. So these are some photographs of our training program in some training centers. Just an example. Okay, that's all. Thank you very much.
Thank you, Blanca. It was very nice. You have a lot of training providers in Spain. Graziella, are you ready?
Yes, I will share the screen.
Please share your screen. Graziella from Romania. Graziella took part to the consortium in the beginning as stakeholders. And Graziella does a lot of training in Romania, right? Graziella, please.
Yes.
We can see your screen. You can put in full mode. You
Yes.
can start your presentation.
First of all, thank you for the opportunity to say some words about our work and the contribution in the project. And I want to thanks to the organizer and the leader the institute from UK. And to say some words about our efforts, the efforts of Romanian General Association of Refrigeration activity and some results and contribution for this refrigerant air conditioning work in the field of natural refrigerant and environmental protection. Here you can see some examples of our association activity, how we organize national training, certification, and many others in Romanian national regions. And also you can see here other examples from our activity from Bucharest, Timișoara, Bacău, Cluj, Craiova, important cities in our country. As you know, Romanian General Association of Refrigeration is a professional non-governmental deploying its activity in the field of refrigeration and air conditioning. And also you can see here images about how we organize training and certification, and also how we deliver training. And how in this field of EU regulation 517/2014 F-gas regulation and its relevant subsidiaries in this pandemic time. Also, you can see how we offer the certificates and how we cooperate with other entities, national level, with a patronage for refrigeration and air conditioning, the private sector in our country, close cooperation with ministries, Minister of Environment, Economy, Labor, and also other entities like standardization, and not in the last part, and I will show you some examples of academic activity and universities. About this academic activity, you can see here some examples of our work in the last 2-3 years pandemic time, in fact. So we attended a lot of conferences and congresses, and we sent and present a lot of articles about natural refrigerants. For example, Gustav Lorenzen conference with natural fluids in Japan. Also, a lot of articles about eco-efficientization, renewable energy, geothermal, and retrofit, and heat pumps, and other comparative refrigeration. So you can see also here some examples of how we disseminate the results of this project in the only one journal we have in our country, Frigo Clima Journal, and some examples of books we create about renewable energy and natural refrigerant, like this PhD master thesis, and this was finished in 2021. Also, you can see here examples from the project, how we organize training, how we delivered, train the trainers event, theoretical and practical training. You have also examples from this pandemic time, because we have a lot of information about our activity. It was a huge effort for our association and our technicians and our trainers. And you have here examples of theoretical training. This was online because the pandemic, and also practical training. And you can see here how we solve in person this time, face to face. Also, you can see here examples of practical training and theoretical training with CO2. and our trainers here very well prepared and high level education, and how we offer the certificates and our setups and equipments. Also, you can see here, as you see, because this was a small problem in the project, we tried to build setups with our possibilities from association and equipments and for CO2 and flammable. And you can see here the activity between 2020 and 2021. Again, you can see here the last image with our activity in this pandemic time, 2022, because this didn't stop in our country. And unfortunately was more theoretical training because it was difficult to teach them face to face, and it was not allowed, in fact, and we respected the legislation in our country. And you see our last courses in 2022 with certificates and technicians who finished this winter. In conclusion, in this Real Alternatives for Life project, we certified with our 112 technicians for flammable and 76 for CO2, and we planned more than 90 already in the most important cities we have in our country: Craiova, Sibiu, București, Bacău, Cluj, Timișoara. Also, we organize meetings with companies because we have to convince them about and to explain the strategy of natural refrigerants. And I'm talking about ammonia, CO2, hydrocarbon, water, and air, the big five. Also, we made advertise, and you can see in our site, our journal, in newsletters, banners, and conferences with natural refrigerants we organize, and you have here our country with 8 national region. I want to thank you very much, and again, congratulations the organizer for this important.
Thank you. We are at 283 participants now at the moment. I think Liana is back. Let's try again from Armenia. Thank you, Graziella. Please stay with us.
Okay, stay safe and peace to everybody.
Peace to everyone. Liana, we can see you very well from your mobile. Try to speak, please.
Yes, hello. I would like to greet everybody, and good. And now I will try to share my presentation.
Thank you, Liana. Nice to have you with us from Armenia. I saw your training centers many times, and it's wonderful. So it would be lovely to see the training you did there. It's a UNIDO equipped training center, if not mistaken, right, Liana?
Yes, you are correct. It's problems with projecting my presentation on the screen. Is it possible if I ask Sylvia to do so?
I can do it from my side.
Yes, the training center was established under the project implemented jointly with UNIDO and the government of the Russian Federation, and its inauguration took place in 2018 at the Interstate Ecological Council of the CIS countries. On the picture, you can see the Minister of Environment of Armenia, the Environment of Belarus, and also the Deputy Minister of Environment of the Russian Federation also attended the event. And the coverage of the event was quite significant, both in various Armenian media and so in Russian media as well.
Can you see the third slide?
Yes.
I move it.
Okay, thank you. Here on the picture, you can get a glimpse of the inside of the training, where you will see the various training simulators to the right and to the left from the table. And here we come with the Real Alternative Program accreditation. A decision has been taken to get the center certified under the Real Alternative Program, taking into consideration its significance and the wide usage of alternative refrigerants that, as has been duly mentioned by the previous speakers, by Mr. That highly qualified technicians in the market. Thus, training has been conducted by a trainer, and 5 trainers were certified under the F-gas and Real Alternatives components. Here you can see the names of the certified technicians that have already undergone the training at this training center. I'm not going to read them one by one, please.
No, not needed.
No. And I just, no, it's okay. If that was the last slide, I just want to underline that we managed to certify 45 technicians under the Real Alternatives program. At the moment, due to the pandemic, the new training is taking place, but very soon the center will become very active, because Armenia is currently working on making the certification mandatory. So that would mean that very soon all the technicians will need to undergo training and get certified.
Well done. Good news. Thank you, Liana. Stay with us. Thank you for being with us today. 290 participants. I need now Stepan to go on the stage from Czech Republic. And we have already some questions. I will take the question at the end, if you don't mind. I have a question for Didier Coulomb. I will ask him at the end of this round. So Stepan, please come with us and share your screen, please. Stepan, are you with us?
I am here.
Very good. You can turn your camera on. We can
now
see
hear me?
you.
Okay, because I was in the interpretation mode.
Yeah, you are multitasking.
Yes, it's not easy.
No, it's not easy, but you're doing great. So share your screen, please.
Wait a second. It's coming up. Meanwhile, I can say my greetings. My name is Stepan Stojanov. I come from Czech Republic, and I am General Secretary of Czech Association of Refrigeration and Air Conditioning. And I hope I can share the presentation. Can you see it?
Yes, we can see it.
Okay, I'm putting it in a full mode.
Yes, please.
All right, so
we don't see presentation mode. We see it in double slide mode.
I have 2 monitors, so
yeah, I can imagine.
Okay, now?
Perfect.
Okay, so here you can see that our association joined also the Real Alternatives for Life training program. What we do is basically the same as the speakers before me told or were speaking about. We are a national association responsible for providing also training and certification for F-gas. And we also do other types of training connected with refrigeration, air conditioning, and heat pumps. So it was only logical that we joined the Real Alternatives for Life program. It happened in 2017 when the second round of project was started. The project already had its online version, And with the second phase, we were happy to join and to share information about also theoretical and practical training. So in 2018-19, we trained, we did the train the trainer projects. We visited training centers in Germany, Italy, Slovakia, and Poland, which was very useful. The best benefit for us in this program as association and training centers was to share information and to see how in other countries they do it. And through this, we acquired really important information and useful information how to do the trainings in the Czech Republic. Also, I have to thank our colleagues from Slovakia because we shared the trainings at the beginning, and we were able to do the trainer events together. In 2019 and 20, with a grant from Czech National Environmental Fund, we were able to get some financing for equipment of 2 training centers, specially made and focused on flammable refrigerants. We built and equipped the training centers in Prague and Brno, which are the 2 largest cities in Czech Republic. And we started the first training in late 2019. So you can see it was just before the COVID pandemic. In 2021, we opened the 3rd training center in Ostrava, the 3rd city in the Czech Republic. So far, during this period, we have conducted 15 trainings for about 140 people. All these trainings were done in person. And during the lockdown, we had to do the trainings online. So 64 people attended our online trainings on flammable refrigerants. We've done 6 in-house trainings for employees of companies because our equipment enables us not only do the trainings in-house in our training centers, but also to go to the companies and do the trainings on their side. So we've done trainings for employees of companies like Train Technologies, Hauser, Weiland, Faiveley Transport, and many others, which was very appreciated. And besides the trainings, we were also able to share the information about the safety of the facilities where they are mostly production companies. So the safety on place in the production. There's the e-learning program, which is very useful in this program, in this project. Has been translated to the Czech language, and the Czech mutation has now over 1,700 visits, which is very nice. And we enforce the obligation to undergo the training of the practical training on flammable refrigerants in our fire protection safety standards. So the safety standard in the Czech Republic now says that when a system which includes flammable refrigerant is installed and serviced, the person who does it needs to have practical training and certification through Real Alternatives for Life or similar program. Here are some photographs from the training centers. This is our first training module with propane, and below you can see some equipment. These are the other training centers. Some photographs from trainings in progress. Here are the trainees after they were able to get their certificates. That's all from me.
Thank you, Stepan.
for having me here, and I will switch again to the translators channel.
Thank you, Stepan. Thank you for your effort. You're doing a great job.
Pleasure.
And it's important, the equipment, the laboratory should be fully equipped. And through the Real Alternatives project, we always focused a lot on the equipment because the practical part in the alternative refrigerant is the most important part, the safety issues. Peter, please, is your turn from Slovakia. Thank you, Peter. You're very active, always in the normative parts of our sectors. You're doing as well a great job also in the Real Alternatives project. Please, we can see it, your screen. If you can put your presentation. Yes, we can see a nice picture of us.
Yeah, sorry.
No problem.
Photos. Okay, so I put onto the
full presentation mode, please.
Presentation. I hope you can see it.
Yes, perfect.
Thank you. Thank you. Greetings from Slovakia. It is this small green part in the middle of Slovakia. We work according to the regulation of 517 and also regulation 2015-2067, which has substituted regulation 303 from the year 2008. So the regulation 2015-2067 has introduced alternative refrigerants, alternative technologies, energetic efficiency, safety work. So it means it means nearly complete information about alternative refrigerants. So it was quite a big challenge for trainings and certification of personnel, which we have started according to this regulation since 2016, using standards, our experiences, technical literature from Danfoss, Checo, and so on, and also EU project Leonardo da Vinci, natural refrigerants 2009, and also we have joined EU project Real Alternatives, and it has helped us to improve our training and exams. So certification we have started in the year 2016, and we have already 407 certificated technicians. On this graph, you can see certificated technicians on F-gases and alternative refrigerants. The ratio of alternative refrigerants is in a yellow color, and on the next graph you can see the ratio between the category 1 and category 2 according to the regulation 2015 and 2067. Qualified technicians are needed. Production and import of new products with alternative refrigerants is on the rise since 2016. We can follow quick decrease in CO2 equivalent. You can see that this decrease is nearly 50%. But what is important to say that at nearly the same level of purchased mass of refrigerants, and it is very important, this effect which was expected, and I think it is great. On this, we can see here alternative refrigerants in new products that they are on the rise. On the first graph, we can see that there dominates refrigerants R32, but if we take these refrigerants take off, then we can see that dominates CO2, follows ammonia, propane, isobutane, and so on. How we do the trainings and tests? We have ABC tests. It means one question, more answers. We have more than 400 questions, and we use also graphic tests. It means 3 figures, and one of them is correct, and we can have different types of such a graphic test. We can do also oral exam online using our technical equipment for A2L and CO2 refrigerants and so on. Electronic system in Slovakia links training and certification to reporting and data processing. It means that we have a program which is on the It's simply web application where data can be sent by mobile, by tablets, and there is a connection between service companies and operators by QR code, and we can read the data from the logbook through this QR code. We can add to the logbook different inspections or tests, right? Like regular inspection, nominal, repair, inspection, after repair, strength and tightness test, vacuum test, and so on. And also we can add risk assessment. It means evaluate probability, affected person, remedies, and how this risk can be handled. So this is our approach to the realization with the help of this project, Real Alternatives for Life. So that's all. Thank you.
Thank you,
very much
Peter.
for your attention.
Thank you, Peter. The logbook, online logbook is very important as well for the next revision, will be an important issue. I have finished this part on stakeholders' experience. I think it's very nice to have this different experience from all over Europe. I will have in a moment Poland, a trainee, so a recommendation that who took our training. I would like to have a question to Didier Coulomb, if it's possible. Is Didier Coulomb here with us? Yes.
Yes, I am here.
Okay, a question that is very general, but is very important. In particular, is asking, what is the future refrigerants in regard large system air conditioning? What do you think is the new refrigerant in large systems air conditioning?
Well, first, I'm convinced that we will have to go through very low GWP refrigerants. You have some transitory refrigerants, which are lower than the previous ones. But in any case, even if the next goal, for instance, the European Union is 2030 with a reduction of 79% of the CO2 equivalent, very soon we will have almost 100%. So, except in various small applications and certainly not air conditioning. So, what kind of refrigerants we could have? It is the same also for other most applications. Well, you have the main problem is safety. You have this ammonia, for instance, is a very good refrigerant, but you have regulations against the possibility to use ammonia in near a live room, and so for air conditioning it could be of course a problem. CO2 is good, but you have problems of investment costs, which are generally a little higher. Very low GWP refrigerants such as hydrocarbons are very flammable. So once again, you will have some regulations against it, even if we try to modify the regulations in that international level and at the European level, in order to have more possibilities to use these refrigerants. And you have mildly flammable refrigerants, such as HFOs or mixtures or combinations of them. The only problem with HFOs is not security, sincerely speaking. It is the fact that you have some possibilities of pollutants such as TFAs, and you have some countries which now forbid these refrigerants, which are not called natural refrigerants. So it will depend on the various countries regarding that. I saw also in on the screen the fact that there is also a question regarding recovery, refrigerant recovery. I would like to add the fact that it is certainly a problem which is not enough addressed currently. And the problem of bunks, of course, is important. We cannot release the bunks into the atmosphere. So we have to recover the refrigerants, to reuse it, to transform it, to destroy them. We have some installations currently in Europe which can do that, but not enough. And it is certainly something which shall be developed.
Thank you, Didier. Okay. I think your answer was perfect and was very important for this topic, of course. So we're talking about training of the present, but the future is even important because we are talking about training what is the present, but the future we'll see alternative refrigerant. So we are going to train on alternative refrigerant in the future. I answer only 2 questions, which are on the question box, which are for me. Albania would be nice to have in the real alternatives program. I've been in Albania myself. I've been in Tirana. There are 2 associations, so please join us so Albania can be part of our project as well. Nikos from Cyprus is asking about the future certificate real alternatives, if it's going to be a prerequisite for F-gas certificate in the near future. We don't know. We know that the gas regulation revision is going to come out soon, in 1 month probably. We hope that alternative refrigerant training and certification could be a top up added to the gas certification for safety reason mainly, as Didier told earlier. In Spain is already like that. So let's see. So thank you so much for this round. Now I ask Gabriella, Igloo Poland. Thank you, trained and certified by Prozon in Poland, in Warsaw, I believe, in Warsaw. Gabriella, you have a video, right?
Yes.
Can you share it with us?
I was planning to put the video on in a second, if that's okay.
Please do it. And if you can talk on top of the video, would be very nice.
No problem. Because I would like to welcome everyone, and my name is Gabriela, and I am a sales specialist in the export department of the Polish company Igloo. I have been working for Igloo since 2019, and I would like to introduce our company and the benefits that the company and its employees have gained thanks to the training on refrigerants in refrigeration and air conditioning carried out for us by the Prozon Foundation. The company Igloo was established in 1986 as a family business by Mr. Władysław Wodarczyk. Currently, the company is run by his sons, Miłosz and Przemysław. Igloo is a Polish manufacturer of refrigeration equipment, inverter condensing units, cogeneration units for the food industry, confectionery, bakery, and gastronomy industry. Igloo is also known as a recognized manufacturer of dehumidifiers and inverter heat pumps for individual customers. We have been operating in the market for over 35 years, and we are constantly developing, investing in the latest technology and human capital. We offer comprehensive cooling services, including the delivery, assembly, and servicing of equipment, as well as the design and implementation of comprehensive cooling installation based on multi-cool inverter units and cogeneration units. We also implement new refrigeration technologies based on our own innovative solutions integrated in cloud environment, allowing for remote data management. We care for the environment, taking particular care for optimizing the energy consumption of our equipment by producing modern energy efficiency system based on innovative...
You have 5 minutes, right, Gabriella, right? 5 minutes, okay?
Yes.
Take care not to exceed it.
Right, okay, no problem. And provide cooling and heating energy, and to make it possible to realize the idea of zero energy buildings, our ecological systems solutions enable the creation of new energy management systems. The main refrigerant used in our equipment is natural and ecological propane R290. So I have told you a bit about Igloo, so I would like to invite you to see our video. I will present now. Just bear with me one moment.
Igloo, more than cooling.
Okay, and that was the video. I would just like to say a few more things, if that's okay.
Please, about the experience you had in training.
Yes. So I would like to provide you with the main benefits that the company and the employees have gained thanks to training in refrigerants and air conditioning carried out by the Brazing Foundation with the Real Alternatives for Life training program. This training took place in January 2020 and was attended by a total of 12 employees from the 3 of our departments, the R&D, production and service department. It was a 2-day training conducted in our company by lecturers of the Brazing Foundation, PhD Tomasz Łokietek and PhD Piotr Kopeć. The first day of the training lecture of the Brazing Foundation included theoretical lectures and the second day practical exercises with the use of the flammable refrigerant propane. At the end, a theoretical and practical exam was held, which all training participants passed, and they were awarded with the International Real Alternative Certificate, confirming the theoretical knowledge and practical skills of working with flammable agents. Thanks to this training, our employees gained greater and deeper theoretical knowledge about flammable refrigerants and working with them. They also acquired many new practical skills in working with flammable refrigerants. During practical exercises, they learned, among other things, how to safely repair leaks in refrigerant system filled with propane. They practiced recovering propane from a leaking system and vacuuming and nitrogenizing the system several times, up to the point where there is no residual propane left in the system, and the system leak can be safely removed by the flame breathing. This training increased the knowledge of flammable refrigerants and working with them, also among our employees who did not participate directly in the training, including company management. As a result, we are able to build better and safer filling areas for our propane production at the production sites. We originally intended to build based on our own ideas, but thanks to this training, we decided to use professional propane filling equipment from the Italian companies Galileo TP process equipment. We also installed professional helium leak control equipment, also made by the Galileo TP process equipment. And the conclusion, thanks to this training, the flammable refrigerants in refrigeration and air conditioning, we can better and safer design, manufacture, run and service our propane refrigeration devices, which also thanks to this knowledge, we are better and safer. And that's all. I would like to thank you for having me today, and I wish you all.
Thank you, Gabriella. It was good to have a witness of our training. How was it successful and how increased your skilled in your company. So thank you so much, Gabriella, for that.
Thank you.
We had a few questions in the chat box about the contents of the training. I think I can keep it on the training side when we do training itself. Now I would like to ask Graham, my good friend Graham Madman from London South Bank University, to join us. I can see you very well, Graham, and I would like to hear you as well. Yeah, I can see my face as well. Very good.
Hi everyone, and thanks very much, Marco. And I'm Graham, and I'm representing London South Bank University and the Institute of Refrigeration. And I want to talk a little bit about the journey, the real journey that we've been through from real zero to real alternatives for life. So I want to give you a little bit on the background to why we started doing what we're doing and why we're doing it, and then also perhaps look forward to potentially what the opportunities are next. So Real Zero is the grandfather for real skills and real alternatives for life. And it started as an acronym in about 2008, 2009. And Miriam Rodway, who's from the Institute of Refrigeration, and I, Miriam's speaking next, came up with the need to focus on refrigerant leakage. And we came up with this acronym, Refrigerant Emissions and Leakage Zero. And it was a project that started in the UK then, and it's fantastic to see how this has developed over the last 13 years and to see so much activity and so many people on this call. It's absolutely tremendous. And I just wanted to touch little bit about what we've achieved, what the principles of Real Zero and real alternatives for life have been, and then just to look forward. So just a couple of slides, if that's okay. So I mentioned already the acronym, and we initially focused on HFC and HCFC refrigerants. And we used an e-learning approach. And the e-learning approach was about delivering an industry-led approach focused on addressing barriers through skills and making resources freely available, initially in the UK and now in Europe and now in so many languages across the world. It's tremendous. And this slide's a bit busy, but the picture on the left is some of the early online training that we produced, and you can see we've got euros in the center of this because we focused very much on the drivers for reducing leakage, money. And we found that it was actually a really good driver for end users. And on the right hand side, these are some early results from some of the retailers that were involved in the project, and you can see that the emissions have been driven down tremendously. This is till 2013. If you go forward 10 years, you would see this going much further down towards zero, real zero. So it's been really successful on HFC and HCFC refrigerants. But we didn't stop there. We saw a fantastic opportunity and a need. Didier mentioned before the need to focus on big air conditioning and the driver to focus on some natural refrigerants. And the principles are very much the same in Real Zero as it is in real alternatives for life. And we've got a fantastic industry-led program. We're addressing skills and barriers. We've got practical material, and it's freely available in many languages. Before I finish, okay, I just like to just to sort of just really put this out there that we've got this revision for the F-gas regulations, and how tremendous would it be for this material to be incorporated into this. Okay, it's a real opportunity. So for those of you that are on the call that are influential on this is a real opportunity to grab some industry-led material and to use this in something that will encourage so many more to adopt. Final slides. This is some of the tremendous work. Marco, you've seen there. Marco's been brilliant on the project, and we're not going to stop there. Refrigerant leakage is something, but we also have to focus on energy efficiency, and we have a program in the Institute of Refrigeration looking at focusing on energy efficiency. If you want to get involved in this is my email address, mademeg@lsbu.ac.uk. Feel free to contact us. There's a real opportunity not just to stop the journey, to continue it for many years to come. So thanks very much, Marco. Tremendous session. I'm going to stop there.
Thank you, Graham. It was great, great history of real alternatives. We started, I think, in 2013 or 14. We started this journey. So it was a great. And you started before with real skills and real zero. So it was a great job. I asked Miriam to connect. I asked also Miriam to say a few words about women in refrigeration, if you can, because Berin Erbey is asking for it. I also say that Israel want to join real alternatives. Welcome. If you want to do training now with an available training center, okay, you can choose wherever you want to go. You know, there is no preferences, but it would be nice to have Israel in the group. So thank you so much. One more things before I leave to Miriam. We have a lot of questions. The technical one will be answered during the training sessions, so with Marino and with Kivanch, but also take a note that we have a LinkedIn page. All the questions will be put in the LinkedIn page and will be also answered in that page. So we all have connection and we join each other also in this LinkedIn page of Real Alternatives. Miriam.
Thank you, Marco. Now, you see my screen well? Yes.
Very good. Full screen, perfect. Everything's perfect.
Oh, good. Right. So we will go quickly because I know you're very keen to try the training that will follow this short talk. I wanted to remind everybody that as well as the practical training provided by our partners that we have heard from today, there is also the possibility to do some theory training, just the knowledge, not the practical, online. This has been very important in recent years when training centers have had to close for safety and COVID. And now you can still continue to use our e-learning. It is free for everyone to use. It is a great tool for anyone in any business, but also it's a great tool to support the trainers in helping the people coming on their training course to understand some theory before they arrive. So in the training, so it makes good use, good economic use for people to prepare before they come to a training, and it costs them then less time. We understand training is a very big investment for people. So the e-learning element gives them some theory knowledge. It is available if you come to our website, realalternatives.eu, and there you will see, here is a picture of our website. Here you will be able to register for the e-learning. And for those of you who have not tried the Real Alternatives before, who are on our call today, nearly 300 people, you can register here and you can see the material and see the good quality material. And we hope, as Graham said, that you will share it with policymakers, with your environment departments, and encourage the EU revision to use. This is available, it is tested, it is developed by people like you in the industry. From this website, you can use, there is many material, there is booklets to look at. There is also the list of all the different countries involved in our project. If you wish to follow up with somebody who's spoken today or from another country, you can go to this website and find the details. And the website is available in many languages, multiple languages. You select which language you want to use, it will be already translated for you. So if you go to our e-learning, you must register, of course, the e-learning. And when you register, you will find you then have access to 9 separate modules. The most important, introduction to what is an alternative refrigerant, and then the second most important, safety and risk management. Didier also spoke to this earlier about the issues around alternatives, refrigerants, high pressure, the risk of flammability. So these 2 modules are essential for anybody to study the e-learning before they continue. Here, I just give you some examples of how this works and some of the topics within each e-learning. And as you complete each section, there is a little blue tick, which will show you to help you to progress. Another example page, the differences in design. So our program is not to teach people to be refrigeration engineers or designers. It is to teach them the difference when they're using low GWP alternatives, how they need to do things a little bit different to what they already do. We talked about recovery also in one of the questions. We have a whole section here explaining how to recover safely in our maintenance area. And also to remind you that we have videos. We have done training videos within the e-learning to make it very clear how this works on live systems and also on training systems. Here are the different videos. They are embedded within the e-learning, but you can also go to YouTube. If you go to YouTube and search Real Alternatives for Life or UCLL Energy, you can find our training videos. These are freely available for everyone to use to support training in their businesses and with their trainees. There is a basic test system within our e-learning. This is not an exam, not an assessment, just to test progress in the learning to help people if they have understood. And certificates, if you complete the full e-learning, you can get a little white certificate. You can download this. This is not assessment, just a certificate. It's very different to the blue certificates that we've seen pictures of today with our partners, where they have done a in-person training and a full practical and theory test. Here they can get the blue certificate. On the right is orange certificate. This was given out during the time when training was not possible in real training centers. This was given out as a more flexible option for remote training from centers. So you understand how we are flexible with you. And just to remind you, if you are from a country which is not currently involved, please go to our website. Here you can find out how you can get more involved. If you are from an employer and wish to do some training, you can find the list of the training providers available in your country from the website, and you can talk to them to set up or join a course. And of course, Marco said we had lots of dissemination activity. Marco asked me also to say a word about women in RACHP. You see, I have here behind me and also on the screen. The UK, we have a strong network to encourage women to join our industry. We talked earlier about the need to improve skills and the need to have many technicians available. And this is something we are encouraging people to do. And we are very proud also to work with the International Institute of Refrigeration on their ICAR Careers in Refrigeration project, doing a great deal of research and regular events at the International Institute of Refrigeration conferences to encourage women who are working in the industry to support each other and improve their training. In the UK, we're doing practical training for people who are working in support roles, and they go along. I think this week we have a workshop where they'll be doing refrigerant handling and air conditioning system operation. So there are lots of things that we can all do to support and address careers and skills in our industry. And I'm very pleased that so many people have joined us, and we're working together to improve skills for the future and for the achieving of our all low GWP aims for the environment. So thank you, Marco. This is it for me.
Thank you so much. I can see that there are many questions and also answers in the chat box. I just reshared an answer from Didier Coulomb in the chat box about where we can have more information about facilitation on future refrigerants, right, Didier? You want to answer this one while Marino Bassi is going to connect for the next part. And thank you to Miriam for his e-learning experience. Was very useful, of course. We need to know how to assess this training, which is most of it is free of charge, as we said. And if you do, the main part is practical. Of course, you have to go to a training center to do the practical part, which is the most important part.
Marco, so just very shortly to complete my my answer to the questions and the questions which was in the chat. First, regarding the possibilities of systems for low global warming refrigerants, don't forget the possibilities to have indirect systems. And for instance, the district cooling is something which is expanding all over the world because it allows people to have some centralization of the risks, which is better for the air conditioning especially, and it is used in Paris, in Stockholm, in a lot of various towns now. Regarding the possibilities to have very new technologies, I would like to insist on the fact that we have very few possibilities currently. Regarding the refrigerants, there were some studies, especially in the US, in order to check all the possibilities of molecules. And there are very few molecules which could be new molecules, and they are very near the current molecules. So we can have a lot of various new molecules, but near the current ones with the same kinds of problems with the current ones. We also try to have to develop some non-refrigerant technologies without refrigerants. And we organize every two years conferences, TERMAC conferences on magnetic refrigeration, on or other solid state technologies. there are some possibilities that currently it is only used and possible with the current technologies for very small systems. So regarding the questions of very large systems in air conditioning, currently we don't have very new possibilities, but we try to explore possibilities, and I hope that in a few years it will be possible to give you other solutions. Currently, it is not really possible.
Thank you, Didier, for complementing the answer. It was very good. I ask Marino Bassi to come on the floor. I think I can see Marino. I think I can hear you, Marino. No, I cannot hear you. No, I don't hear you, Marino. And you are not in mute. No, I don't hear you, Marino.
Marino, can you please try to unplug and then plug again the headset, please?
Prova a togliere e rimettere le cuffie. In the meanwhile, they're asking Greek. Greek is available. Greek, it is in our system, but we are just uploading now. So Greek will be in few days available because was some problem, but Greek, it is available. Greek, it is available. Marino?
Can you listen me now?
Yes, was quick, very good.
Okay.
Can you share your screen, please?
Yes, sure.
So now we are starting the training about flammable refrigerants. Marino Bassi is a trainer of Centro Studi Galileo, Elettrici del Freddo. He went everywhere in the world, you can say. You have been to Caribbean to do training, right? You've been to Granada doing training.
Nice training, that one.
Caribbean was nice, right?
Yes.
Was the real alternatives training. So
yes.
Marino will teach us about flammable refrigerants. Thank you.
Thank you for the introduction.
Keep tieni il microfono vicino. Keep the microphone closer.
Yes. It's better now?
Yes, it is.
Okay. So a quick introduction from my side. For many years, I am in the refrigeration field, engaged with Embraco, and now is NITEC, is in the NITEC group. With the Centro Studi Galileo, I already said sometimes that I have the record because I hold the first training of the Centro Studi Galileo. And regarding flammable refrigerant is part of my training. Flammable refrigerant started again, let's say, after the first period of refrigeration, starting again to be used 30 years ago, practically, 1992, 1993. With Centro Studi Galileo, we hold several training, even before real alternatives. I can say that with the real alternatives, the life, let me say, of the trainers and the trainee is much more comfortable. Is considered for the user and also for the trainer an excellent training. Okay, the scope of my presentation is to evidence the good practice for flammable refrigerants. I say that is a demonstrative training. Why? Because what you will see, the information, the data, the recommendation is extracted from the modules that Miriam indicated before, as they are in the modules without elaboration. So it's possible to have a clear idea of the content and the validity of this training. My presentation is organized in this part, flammable refrigerant characteristics, safety design, maximum refrigerant charge in the installation, and safety repairing. I will insist more on safety repairing because here is the moment of the higher hazard for people, for the technicians. As Mirja said before, real alternatives is not a training to form technician on the refrigeration field. It assumes that already they know when they have skin for the standard refrigerant HFC. But it focuses on the difference between alternative refrigerants and HFC with particular attention to the safety aspects. That is the more the dominant argument. Flammable refrigerant characteristics. Let me start with this. Here is the list of refrigerant inside the real alternatives. The flammable refrigerant that I speak about are this group of the R32, 2HFO, and the AC. Also, ammonia is flammable, but the the dominant hazard is the toxicity, so it's not considered in this training I am doing. Here are the table with the characteristics of the alternative refrigerants, the flammable, let we say, and there are the type of refrigerant, HFC, HFO, and hydrocarbons. The key fact that is the key hazard, lower flammability for HFC and HFO, higher flammability for hydrocarbons. The GWP is close to 1. And typical applications, as you can see, the hydrocarbon are mainly dedicated to domestic and small commercial system for R600A, chiller and integral system for supermarket and other location, and the same for propylene. Saturation temperature indicate the proper application. However, they are used also for example, propane is used both in low temperature and medium temperature applications. We are speaking about flammable refrigerants. The safety classification regarding the refrigerants is in the ISO 817, and also EN 378 include the A2L refrigerants. The classification is made on this parameter, the lower flammability level in percent in air by volume, heat of combustion, and flame propagation, the burning velocity. The threshold for this parameter is 3.5 for the LFL, 19,000 kilojoule for heat of combustion, and maximum 10 centimeter per second for the burning velocity. On the base of these characteristics, the various refrigerants are classified. One that is not flammable when tested at 60 degrees C. This is important, is 60 degrees C. Other, like the NIST, they tested 20 degrees C. And for example, R134A said E is not flammable for NIST, but flammable for ISO and EN 378. In this table is indicated the characteristic regarding flammability of these refrigerants. And you see the A2L classification, that is the mildly flammable, and the high flammable hydrocarbons. It's interesting to note the low flammability level in kilos for cubic meter. Is easier to use these units when calculate the refrigerant charge, of course. And you can see that the low flammability level of hydrocarbons is about 7-8 times lower than the HFO and AC in this list. The auto-ignition temperature is another source of ignition for flammable refrigerants. And the PL is the practical limit that is indicated in EN 378, and is used for simplify the calculation to determine the maximum acceptable amount of refrigerant in occupied space. The PL is 20% of the low flammability limit. And as you can see, it's possible to charge system using HFO, using the A2L, with the refrigerant charge practically 8 times higher than using hydrocarbons. Furthermore, the EN 378 has a coefficient of 1.5 for the A2L, so the refrigerant charge is practically even 12 times more can be acceptable for It depends on the application, of course, but it accepts much higher refrigerant charge. And not important to say for the HFC and HFO is that these refrigerants form toxic products of the composition when they burn. And they form hydrogen fluoride, HF, that with moisture become hydrofluoric acid and has a severe impact on person and animals if become in contact or inhalate this. The hazard with the A2L is greater than with the HFC, normal HFC, A1 HFC, because they can burn in presence of open flame. The combustion, to have a combustion, the condition is to have fuel, oxygen, and source of ignition. For the flammable refrigerants, you have the combustion if there are a flammable mixture, that is a mixture in air with refrigerants concentrated between the lower flammability limit and the upper flammability limit. And to have a flame, you need to have an ignition in the flammable area, the flammable zone. You need to have a source of ignition active at that moment. So the concept of safety using flammable refrigerant is to keep separate these two elements and to work to minimize the leakage and to exclude source of ignition where there can be present a potential flammable atmosphere. Let me see how this applies for the safety design. Just make an example for designing the cabinet or the application. In order to design to reduce the risk, no source of ignition has to be inside a potentially flammable zone. So the source of ignition has to be removed from this zone. If a leakage can form a flammable concentration around an electrical device, this device has to be no sparking type. And this flow chart that is in the alternative, of course, show what is the process to ensuring the refrigerant system are safe. Step by step, very quickly, step one has to carry out the definition of the declassification of the zone or the flammable area, making tests simulating leakage with flammable refrigerant. Then it's necessary to identify source of ignition within the potential flammable zone. I think so that the problem is there. Sorry for this. So I was speaking about the option to eliminate this issue or to reduce these issues. It's quite impossible to eliminate all the risk. So move away from the source of ignition, from the ignition source of the flammable zone, as also recommended by the standard. Replace the source of ignition with a suitable one, that is a no sparking one. And also airflow is important in order to reduce the concentration of the flammable, of the leakage in order not becoming flammable, to keep below the flammable limit, low flammable limit, or locate the source of ignition in an enclosure that doesn't transmit outside the flame, and this can be costly for the small cabin. Regarding ventilation, ventilation can negate the need for changes of electrical devices or put them in an enclosure. It can be used the condenser fan motor, the condenser fan, to run constantly, or a supplementary fan that is switched on with when the condenser fan is stopped. It's important to make tests to be sure that to consider that in case of fault condenser, or if the motor fail, it can reduce the availability of airflow, and care has to be taken, especially if this is the primary protection method for the source emission. Regarding the installation, I just refer to the maximum charge size. The flammable refrigerants have a charge size limitation in many applications. And the EN378 provide charge size restriction for the air conditioning, heat pump, and for all the applications. The definition of the maximum allowable refrigerant charge is based on this parameter. The refrigerant characteristics that I said before in the last table that I showed you before. The access category, that is the occupation of the different area, open to the public or not. The type of system, that if it's for comfort, cooling or heating, or other application, that means if it is for refrigeration, and where is located the location of the equipment. On this parameter, it's possible to go to the table C1 and C2 on the EN378. I can show here this table because the copyright of this, so it should be an infringement if I show this table. The table 1 is for toxicity as dominant hazard, and the table 2 is for flammable refrigerant A2 and A3. A quick explanation on the access category is 3 level, A, B, and C. A is for general entrance, where any people can go there, enter there, without knowing personal safety precaution, like hospital, theater, etc., supermarket. B, only limited number of people can enter, and at least some of them, they are informed about the safety precaution. Is laboratory, manufacturing, normal, let me say, manufacturing and office building. And restricted access category, C, that is not open to the public, and all the authorized person can go there, and they know the safety precaution. And this is, for example, the machinery room and a certain facility, chemical, food, etc. The equipment location has 4 classification. Class 1, when all is located in the occupied space, all the refrigeration equipment. Class 2, part of the equipment is outside on or in a machinery room. Then all the equipment can be in machinery room or outside. Class 3, and class 4 is a ventilated enclosure. Let me make an example of the charge calculation, thinking, for example, to the delicatessen counter of 350 grams of propylene installed in a supermarket. And the intention is to define what is the minimum room volume that can be, where can be allowed to install a system with 350 grams. So the refrigerant is propylene, and we remember that is in class A3. So the table 2 apply. The access category is a supermarket, is open to the public, so is A. The application is not for comfort, it's for refrigeration, and the equipment location is an integral cabinet, so is all the system in the occupied ambit. Going on the table C2, is possible to find for all these A3, that is the table C2, access A, other application, and classification 1, it's possible to find the limit that is 20% of global probability level multiplied the room volume, and there are a cap no more than 1.5 kilos. So the minimum volume is the charge divided 0.2 the low probability level, that is 38 square meters. So using this table is quite easy to define the maximum allowable charge or the maximum volume on the ambient. Now let me go to the central part, let me say, to the real topic of this presentation, that is maintenance and repair. As I said before, this is the most critical activity on a system with flammable refrigerants, and is necessary to carry out a risk assessment in order to define the risk linked to the operation and define the control measures and adopt the control measure to limit the level of the risk. In fact, the different property, the flammability of these refrigerants affect how the system are serviced and maintained. Here is a list of, say, precaution and care that has to be adopted for the flammable refrigerants. It's necessary to work in a very well ventilated and free from source of ignition area, environment. The equipment has to be free from source of ignition. The leak test has to be carried out with the proper sensitive and safe instruments, safe detector for both the flammable refrigerants. The charge amount in the system, mainly with hydrocarbons, is most critical because the charge is lower than when using HFC or HFO. Is less than 50% or 40% more or less of the charge of the standard system. And regarding the recovery or disposal of the refrigerant, is mandatory to recover the HFC, HFO refrigerants, and while the hydrocarbons is allowed to vent in safety condition in the ambient. If the amount is small, like for example 150 grams or let me say also 300 grams, but otherwise also the AC refrigerant has to be recovered. We put here the anti-sparking apparatus to use for the technician, because we didn't spoke before, because the HFC have a very limited ignition energy, even fraction of millijoule. So the electrical static spark can ignite the hydrocarbon, not the HFO or the flammable HFO. The real alternative also include an example of risk assessment that can be an interesting example to start to consider how to organize the risk assessment. It refers to the recovery of propylene in a supermarket, and the risk assessment in general has to consider the likelihood of the event and the consequences of the event. In this case, there are three classes, let me say, three rank of likelihood and three rank of severity. And when combined, the probability of the event with the severity, the combination has to be at a low risk level. So we have to work in this corner of the diagram. And considering the situation and adopting all the necessary measures. Here it makes a short example, like said before, the refrigerator, who are the person at risk? Is the refrigeration technician and shop staff. Which hazard we may consider? There are several hazards. Let me start from the combustion. What to do? We have to work, is also forbidden by regulation, to work in an open area open to the public in a supermarket. So work outside the trading hours, separate, close, or make a barrier around the working machine where you work, and so on, in order to minimize the risk. And because you need to have together probability and severity, the risk, the total risk is likelihood multiplied the severity, and has to be in a low class level. And in this condition, it's possible to go on and to proceed with the repairing operation. The preventive action to do is better to repeat, not only in that list, but the alternative make all this list. The area must be very well ventilated. If it's necessary in an artificial ventilation, a forced ventilation, is necessary to use a fan ATEX approved. Is recommended, is necessary to use a monitor detector in order, if you open the system, if you work invasively on the system, to open the system, is necessary to use a detector. Place the detector close to the system on the floor, because apart the ammonia, all the other refrigerants are heavier than air. Have no source of ignition within 3 meters from potential explosive atmosphere. 3 meters is valid for a small quantity of refrigerants like the one in the integral system. Have a fire extinguisher at least 2 kilos. Now let me see some details. The detector cannot be zeroed out in the background flammable refrigerant label. If not, the lecture, it doesn't represent the real amount of refrigerant in the ambient. It has to give an alarm with noise, audible, invisible, when it reaches the PL, when it reaches 20% of the lower flammability level. The fire extinguisher has to be has to be of the type of dry power or CO2, and is mandatory to use this type of extinguisher only during transport of the flammable refrigerants, according to the IDR regulation. Vacuum pump, well, several standard tools normally used for HFC, not flammable HFC, can also be used with flammable refrigerants. The important is that they are not ignition sources. Most standard vacuum pump can be safely used if only the on-off switch is the potential source of ignition. So it's possible to close the switch of the pump and then plug the pump in a plug away from the potential flammable area at least 3 meters. The discharge of the vacuum pump normally it doesn't generate hazard because the concentration is very low. It's necessary, however, to work in a well-ventilated area. The recovery equipment is different. They have several switches, not only the on-off, but relay pressure switches, and is inside practically is moving the flammable refrigerants So the recovery machine has to be ATEX AX rated, has to be AX approved to be used. The same for the detector. Has to be a suitable electronic flammable gas detector. Suitable, it means safe and sensible to the refrigerant that has to detect. Most of the HFC, standard HFC and HCFC leak detector are not suitable and also are not safe for using with flammable refrigerants. Some details after the details on the equipment, some details on the operation. That some of them are common with other refrigerants. Evacuate the recovery cylinder to remove area before filling with the flammable refrigerants. Do not mix flammable refrigerants of different type in the same recovery cylinder. This is an important advice. When recovering hydrocarbon refrigerant, do not fill the recovery cylinder with more than 45% of the HFC safe fill weight. This is due to the fact of the different density of the hydrocarbons. Hydrocarbons, the refrigerant charge of hydrocarbons in the system, we say, is less than 50%, is around 40% of the refrigerant charge of the HFC, HFO. The same is valid also when filling in a recovery cylinder. Pay attention not to fill it more than 45% as the FSC safe fill weight. Brazing, unbrazing. Unbrazing is the most critical operation because there are an open flame. So all the recommendations said before has to be applied. The area has to be continuously monitored with the refrigerant detector placed on the floor practically. And ensure a good ventilation is preferable force with an AX fan. If the quantity of flammable refrigerant is hydrocarbon and if the quantity is low, it's possible to vent. If not, it's necessary to recovery. The recovery machine, when you recover, is very important to pay attention to recover all the refrigerants from the entire system. It means from all the parts of the system. I can tell that I am informed of an accident that happened. Fortunately, it was not serious, that it happened 3 years ago because it was opened with flame, a system not fully evacuated. In one part, still there was refrigerant. Then run the recovery machine under vacuum to be sure to eliminate as much as possible from all the parts the refrigerant. Fill the system with oxygen-free dry nitrogen in order to wash the system. Then this can be vented in open atmosphere in safe condition, of course, even if the quantity is very limited of the flammable refrigerant inside the washed nitrogen. And then at this moment, it's possible to embrace. And the torch has to be switched on only if the air is well ventilated and monitored with the refrigerant detector. In any case, the preferable procedure is not to embrace, but cut the connection with a tube cutter. And it's important, and is evidence again, ensure that all the refrigerant has been removed from the system. Brazing is a more simple operation, is similar to the A1 refrigerants. It's important to continuously monitor the air in any case with flammable refrigeration detector, have a good ventilation, and then it's possible to braze. Having, as also is necessary to do with the A1 refrigerants, having a flash in the system the proper low pressure with dry nitrogen. The evacuation, we said before that it's important to check to ensure that the on-off switch is the only source ignition, so you can use also a standard vacuum machine, vacuum pump. It's preferable to have the AX vacuum pump in any case, in order to avoid distraction and avoid the use, avoid to take the precaution to switch on and then plug away. In any case, the standard one can be plugged away, as we said before, at least 3 meters. The charging is you are moving flammable refrigerant, so you need again to have the monitoring to monitor the area with the detector, have an excellent ventilation. For the AC, as for the other refrigerants, but for the AC, it's important to use not the LPG, but the AC grade, the 2.5, at least 99.5% of purity of the refrigerant. Then pay attention, do not overcharge the system, because as we said before, approximately 45% of the charge is sufficient compared to the HFC system. And in the integral system, in the small system, where the charge is limited, maybe is 100 grams, 150 grams, the tolerance is important to keep the proper tolerance. 5% is a good tolerance if you have 300 grams. If you have 150 grams, 1%, 1.5% of tolerance is much if it's necessary to replace components, mechanical or electrical components, so it's important to use like for like components. Also, the fan motor, for example, has to be spark-free from mechanical friction. So the fan is in aluminum or plastic. So it's important to change like for like as the cabinet producers produce the cabinet, assembled on the cabinet. It's important to ensure that the sealed electrical boxes are correctly resealed before putting in operation the machine, and also do not modify the component, use like for like, but do not relocate the components, because if the component was placed outside the potential flammable zone as defined by the leak test that we said when speaking about the safety on the cabinet, on the system, you have not to remove, you have not to relocate in other places. Here is an example for the small compressors, for the small hermetic compressors. The standard compressor have an open overload protector that in case of trip make sparks. The flammable refrigerant has to use a closed protector in order to avoid that spark that can ignite the external flammable, potential flammable atmosphere. The same for the starting rig. Real alternatives, the models are all related to theories. Practice is extremely important in preventing accident. Field experience, I said, I already told one to you, for example. Field experiences have evidenced some accidents for repairing operation. So the practical training have an high prevention relevance. Practical training is possible to do this in the approved training provider center, like in Italy, the Centro Studi Galileo that I said before. And after having the theoretical and the practical training is possible to get, or only theoretical, but practical is much better, of course, is possible to have a certificate of completion of the assessment or real alternative for life. But I try to go quickly to recover the time. I concluded my presentation. I am open
very much, Marino.
for questions.
There are many questions for you. So I would like to start with the one from Christos. He asks, based on your experience and the dangers that you have shown, especially flammability, what are the items that must be taken in consideration when there is an installation of equipment in risers or on roofs, especially in warm climate countries? Will this affect the firefighting design of a building?
Well, the installation of flammable refrigerants, it depends a lot from the local regulation, from the building code, and from the fire bodies. I can tell that in Italy is very complicated, the matter. And in Italy recently, 2 years ago, if I remember well, the regulation, there are regulations that approve the use of A2L refrigerants in air conditioning. Normally, application of flammable refrigerants like hydrocarbon up to 150 grams, according to the regulation 335/289, is possible to install without particular regulation, without particular other requirements.
Okay, thank you. So I would like to go then to the next question. It is again for you, but it talks about France. So in case we need any deepening, I see that we have Mr. Coulomb also with us. The question goes from Jean-François. In France, the use of LFR is associated to an assessment risk, which has to be certified by an accredited company as a PAVE or Veritas. Full responsibility in case of accident will be on the refrigeration company who installed the system with LFR. So you should insist on this. A low flammable refrigerant still remains flammable. So in case your question
the responsibility is the responsibility. It depends if the system is a monoblock, is an integral system, and the responsibility, and if it's below 150 grams, the responsibility is of the producers. If it's a system that needs to be installed, so the operator is responsible for the installation. So the liability it remains on the producer and on the installer. No.
I see.
Even following all the regulation, even using AX approved components, even following all the regulation, in any case, this it doesn't free from liability. Who produced the machine, who installed the machine, is responsible for his actions.
So you say no big change.
Yeah.
Is there anything you want to add, Mr. Coulomb, since France was brought up? Or the answer was fine for you?
Please.
No.
It's difficult for me to hear you.
Okay.
Sorry. You asked me a question. I don't understand.
No. There was just France that was brought up in the picture. So in case you wanted to add anything, but Marino was already very comprehensive with his reply. So.
Thank you.
Okay.
Can I add from the UK on this issue also? This is pressure equipment regulation. The pressure equipment directive requires this depending on the category of jointing. So it really is about the category of jointing, and it applies not just France. This is everybody, and the UK also. We have some guidance on this issue.
I think that was, thank you, Miriam. What I think that what is important to say is that EN 378 regulation, the part 2 of EN regulation is harmonized with the directive, with the regulation, with the law in Europe for the PED and machine directive. But is not harmonized with ATEX, is not harmonized with the safety requirements for machine and for the working ambient. So it's following, in any case, this standard is not a presumption that you are in line with the ATEX request, with the safety request for flammability or explosion. Yeah.
Thank you, Marino. I would like to ask you one more question from Pavel. He is asking whether a mix is possible in a recovery cylinder of R410A, not flammable, but 50% R125 and 50% R32 with R32, which is an A2L.
No, the recommendation is not to mix. Is not to mix in any case the refrigerant. Yeah, is not to mix. Also thinking to an eventual upgrade of this of the refrigerant, for example. And in any case, the flammable refrigerant are, when is recovered, are considered an hazardous, dangerous item. Also for transportation, for example. So it's required not to mix refrigerants. Yeah. Mainly thinking to the flammable refrigerants. Even the oil used in the compressor used with flammable refrigerants after evacuation, so still contain a small percentage of flammable refrigerants and should not be mixed with the other oil from other compressor using A1 HFC. Yeah.
Thank you very much, Marino. Your lesson, of course, is always super
It's
interesting.
a pleasure. Thank you.
And very clear, especially. There is also one more question from Antonio Alfredo, but I would leave that for later because actually it does not really involve flammable refrigerants, but the real alternative certificate. So
Okay.
I would like now to move to the next lesson, thanking Marino again.
Okay.
And,
Okay. Thank you.
welcoming Kıvanç, our next speaker. He is Turkish, from Turkey, a board member of SOSİAD, which is also a stakeholder of this program. So Kıvanç, thank you again, and the floor is yours. We see not the full screen, but again the double slides. So I guess it depends. A little on top, there is the display settings.
I think I can do it right now.
Or also hide presenter view is fine.
Hide presenter view. Yes, right now it's okay.
More or less. Can you try again to make it full screen? Okay, now it's good. Thank you very much.
Hey everyone, this is the last slide of the day and I'm getting used to this situation. So let's try to see about CO2 refrigeration and CO2 in refrigeration, what's going on and how we can use it. And today, who is talking? Mine, of course. My name is Kıvanç Aslantaş. I'm a mechanical engineer and I am one of the trainer for the combustible gases and refrigeration cycles. And I am the board of director, one of the board of director of Refrigeration Industry and Business People Association in Turkey, and a project coordinator. Born in 1976 in Izmir, and for refrigeration, more than 21 years, and as a general in the business, as an engineer for 24 years. And I'm married and has 2 children. Today, what we speak about, firstly, of course, history, some legal obligations, main features, safety, one of the very important point for us, and operation and working area evacuations, and some part of the or important part of the system as pressure relief valves. And we will see what about the performances and also what we have to do in the maintenance or during some changing of the components or replacing of the components. As a historical, I'm sure most of us is knowing the CO2 is the one of the first refrigerant used in refrigeration system in 1850s. And then after that, after the CFC and HCFC developing, of course, CO2 is a little forgotten. And start from the millennium in 2000, again, it started to use in retailer system. And today, we saw in the system as a cascade with ammonia plus CO2 as a super low charge system in very, very big also warehouse or very big cold rooms. Safety aspect, of course, CO2 is already in the normal concentration of the CO2's atmospheric area is 370 ppm. And let's say the 1 million, in the 1 million particulars, 370. And if this this concentration increased to 2%, then it starts to be harmful or the healthy life. And then most of us actually in the crowded area, we can feel maybe more than 2%. And then we need to be the, let's say, the fresh air. That's why. And at the last part of this, after that, the 5% is very, very, it can be for us dangerous. That's why for the big CO2 system, we will take some safety and we will see in the other part of our slides. So after that, the 18% is the most dangerous part and anyone cannot stay. So when we see the properties of the CO2 system, is very different from the others. For instance, for 404A is critical point temperature is 78 degrees, but for CO2, very different from the other refrigerant, is maximum 31 degrees and the pressure is 74 bar. And so we have very limited area to work with CO2. This is one of the important points to other refrigerants. And what's going on? If we can use this chart, for instance, CO2 below the 5 bar is becoming the dry ice. So we don't want to be create a dry ice in our system because we need the gases to work to our refrigeration system, gas or liquid or mixture, but not dry. So liquid area and the vapor area is okay. But also we have a supercritical area. We don't want to go this area because we cannot control our system. That's why we have to use some different equipment according to standard refrigeration system. Also, we will talk about this, the other parts. So what is our biggest difference from the normal refrigerants or normal refrigeration system? We can use only these limited parts. Main feature, saturation temperature in atmospheric pressure is minus 78 degree, and critical temperature is 21 degree. We already talked about this. And the typical applications, we can use it retail refrigeration, heat pumps, and integrals modules. Also for the big capacity of the industrial refrigeration, it can be used. So not suitable for the retrofit system, designed for the conventional or non-flammable HFC or HCFC refrigerant. So we should change something. And volumetric cooling capacity more than 5 times bigger than HFCs. Oops, then why we want to use CO2 in our system? One of the reasons. Of course, required compressor displacement less than the regular ones, and pipe size and smaller heat exchangers. But on the other hand, high operation pressure CO2 system has. So its effect on the system design, operates, and especially we need to be careful in the high ambient temperatures, because it can be increasing the pressure. And please remember, we don't want to go supercritical phase just for the reason of the high ambient temperature and high discharge temperature we have in CO2 system. And for the low temperature system has the 2-stage compression. For operating pressure, maximum operating pressure is typically 90 bars. And the condensing pressure is, for Cascade system, typically 35 bars. So 5 times or more than 4 times higher than the regular refrigeration system, the standard or conventional refrigeration system. So just on the higher operation pressure have an effect on the rating of the components used, pipe thickness, mechanical joints should be avoided wherever possible. Control equipment setting is different from the conventional one. And tool, the special tool used to access the system, and refrigerant recovery equipment is those equipments different from the conventional systems. So also we need to be say something about some part of the system. For instance, pressure relief valve high side in transcritical system can be set for the 120 bars, and operation above the critical point of the transcritical system should be 90 bars, and intermediate pressure in transcritical system between 35 and 65 bars. That's why in this side, in the Cascade system, the low stage, we also need to be 40 bars pressure relief valve. And for again, for the low temperature evaporator, typical pressure is 15 bars, and high temperature evaporator typical is 30 bars. So after the expansion valve, as you see, for low temperature and high temperature evaporator side, approximately 5 times higher than the conventional system. They have the 5 times higher pressure. And our cylinder standing outside in unbranched ambient temperature in the 5 degree, only 5 degree in the outside, the typical pressure is 40 bars. So we need to be careful as all the other the high pressure gases. And if we compare CO2 system operating pressure with the others, for instance, this is for R32, This is 404A and CO2. Is a 70 bar in the same conditions, same outside temperature, and 404A approximately 10 bar, and R32 approximately 15 bars, but CO2 is 70 bars. When we come to the system types, it's also a kind of the historical develop the system. The first system, the pump secondary system, is only used for the low temperature, and we need to be one pump is a liquid circuit, and for the high stage side we have the secondary system without CO2, and CO2 is only using as a liquid phase. This is for the first system. And then what is the difference from the others? This system typically used for the chiller, and for the first site it can be HFC, HC, or ammonia, doesn't matter for the first cycle. But at the end of the day, for the low temperature and for the liquid circuit, we need to be a CO2 liquid receiver. What is the advantage? Being volatile, it partially evaporates in the heat exchanger. So, and we can reduce the delta T across the heat exchanger. We can design the system very smaller heat exchanger according to conventional one. And of course, the higher density of the CO2 means is we need the less pump power. So system being to be more and more efficient. The second system is the standard cascade system, is very common used in CO2 applications for the startup time, especially for the retailer in the beginning of the 2000s. So one side is the high stage system and the other is CO2, but this system different from the others because we have direct expansion in the system. And also for the first part of the cycle, again, especially R134 or 404A, very common used, those type of system. And generally, CO2 working below than 40 bars. So it's for the startup time. This system used very common. It's very typically for the R410A according to pressure, but of course a little higher than this. And also CO2 condensers in Cascade heat exchanger, rejecting heat to evaporating high strength refrigerant. So it's also used for a while. And then for the, especially for the conclimate, some systems start to be being transcritical one. It's a standard system, as you see, standard equipment, compressor, condenser, liquid tank, expansion valve, and evaporator. But also we need two special equipment for the system. One of them is regulation valve after the condenser to regulate the pressure between the condenser and the liquid tank. The other is we have another regulation valve in the system we need to it, especially when the system stops, when the refrigeration doesn't need the system. If the ambient temperature is higher, then CO2 pressure can be increased suddenly. Avoid of this, just to be balanced to this line, we need this equipment. So in this system, condenser is calling it gas cooler because we cannot provide totally liquid as the other conventional system condenser. That's why for the CO2 applications, we call it the gas cooler. And of course, pipe diameters is smaller than the others because we have very, very big volumetric volume according to conventional refrigerants. And typically for the transcritical system, as I told you, using in the cold climate, not for the warm or the, let's say, the higher or tropical climate, not suitable for the CO2 systems. And then the booster start to use. I think it should be 2007 like this, and is a standard booster system. Again, direct expansion. But for the booster system, okay, we use the common gas cooler. We use the same regulation valves, but we need to use a frequency converter because CO2 conditions can be easily changed. That's why to provide more effective control, we should use the frequency converter. What is the a kind of obligation for the system? And with the parallel compressor, it start to be play, and then especially for the winter time, to provide better efficiency, then we start to use a parallel compressor to balance also capacity and provide the good efficiency of the system. And also this system is allowed to the heat recovery, what is very important, especially for the winter time in the cold climates. And really the system efficiency is increasing maybe more than 5 times according to system capacity or the other equipments. And then ejectors came to the CO2 system. And what is ejector? Ejector is a kind of collector, I can tell, and also is the balancing of the air pressure, and it's allowed to more than 40-degree ambient temperature working. The system is more efficient than the conventional system. That's why it's very, very important equipment. How it works? There is just some nozzles is working, and according to system capacity, these nozzles working. As a general, as shown in the shame, for instance, these two lines is being as a maintenance, but for the 4 nozzles is working according to capacity, and it's very reactive solenoid valve system and very fastly react. Okay, just I want to recap on the generations. It start for the, let's say, new generation with booster, and then parallel compressor is join, and then ejector is join. So the system increase according to create more efficient system, according to create more available for the all climates for CO2 system. If we can see the performances according to 404A in the regular system as a regular Carnot cycle, we can see required displacement is very less because of the volumetric volume, but CO2 is less than the others for the standard system. But what we talk about booster with parallel compressor, booster with parallel compressor plus ejector. Let's see some different cities all around the world, the performance comparison. CO2 booster, parallel compression, and parallel ejector system. This comparison, CO2 with 404A, some differences, and 404A except 100%. See the results. So today, if we can consider to, let's say, availability of the components and let's say, more demand from the market, and also, of course, the more experience for the technicians, and we need to be less carbon footprint. We don't want to increase the energy consumption. We can say with this scenario, CO2 is being more and more popular in refrigeration system all around the world. Why it's efficient? Low pressure drop, because the system working in the very high pressure conditions according to others, and good heat transfer due to the, we need to be, of course, the less heat transfer area, and higher heat recovery potential. So we don't want to also through all the heating to the atmosphere. Instead of this, if we can use in some process, of course, we should prefer to take the heat and use the other process of us. One of the important issue is for the components pressure relief valve. Why? We need some different limitation of or different part of the pressure relief valve in some different space on the system, because the pressure can increase very rapidly. And of course, the safety is one of the most important issue for us. First, safety. That's why. And then, unfortunately, the leakage of force in the pressure relief valve doesn't then reset correctly after a single vent. That's why we are telling all our training, please don't try to reset your equipment, change it, changing. And then it is the, let's say, the most safety application. And of course, we need to be, for the bigger system, the ventilation process. It can be 2 stages of the pressure relief valve. First, the one stage can be open, and the second, and the one can be tried to be bypass from the gas to again enter the system for the suction line from the discharge line to the suction line, and then the second stage we have to vent it to the atmosphere. There's some example. Of course, we need to be specific equipment. Specific equipment meaning is the test pressure should be 120 bar. For instance, goes connections of the cylinders, hoses, and connection components of the system. For the, there is also some special components we have for the replacement during the maintenance. For instance, this is a magnet. If we want to change this heat exchanger, firstly, we have to, of course, close to the valves, and we have to vacuum, but we have no idea about if the heat exchanger has some also CO2 leakage or not in the high pressure. That's why with these magnets also we can open to the solenoid, and we can balance to the pressure in everywhere. Then we should continue to our maintenance procedure. So another things, of course, very important during this process, we don't want to create also dry ice. We will see also, and which standards we can use it. EN 378 and PAD. Of course, pressure equipment directive is one of the important directive for us. And also there is some ISO safety and design classifications. We have to be careful about it. As Marino told, what kind of the classification about the safety group for some refrigerants is an A1, not flammable, lower toxicity, but also it can be very harmful for our healthy. And typically, the first alarm level should be start of the 5% of the ppm. And of course, high pressure, we have to be careful about during the maintenance or replacement process. And for the safety equipment, again, we need to be a well-ventilated area or outside, because normally in outside atmosphere, it can be directly goes and there is no global warming potential or ozone displacement potential. A very high noise level is only, I know the very one dangerous situation is being for the CO2 system is the main reason is the very high noise, because after the leakage, because of the very high noise level, the people create a panic, and then someone, let's say, hit the others. It is very important point. Of course, we need to use the safety equipments as gloves or glasses like this. And dry ice formation, we have to be careful, because by this case, the system cannot work. We stop, but please consider, if we want to be food safety or we want to prevent our foods in the cold rooms, we cannot stop the system. That's why we have to be careful about this. And of course, the other equipment, according to related regulations, it should be suitable for the R744 system. And working area, again, of course, especially for the personal detector can be used, especially for the big machinery rooms. It can be important. So, and typical alarm levels for the personal one, pre-alarm at 1% is the 10,000 ppm, and main alarm start to be 2% in 2000 ppm. Evacuations, we must be evacuated if the system open to air after pressure testing, because CO2 and moisture create a carbonic acid. We don't want to do this, because in our system, it's create a very dangerous corrosion, and the system cannot stay during the lifetime. So we have to be careful about this. For the charge, firstly, we have to check the, fix our cylinder, and only we have to use the right hoses, and it should be stay more than 120 bars. We have to be sure the area is well ventilated. We have to we have to be sure the system working with CO2, and of course we have to use the suitable trolley. Unfortunately, every year, not for CO2, in refrigeration business technicians, due to lack of the experience and due to they don't care about this safety standards, unfortunately they can create some bad effect on their healthy or body. So That's why every time in every training, we make maybe a couple of times repeat these conditions. We already talked about this. And maximum charge size, again, we can see for the EN 378 norms. Of course, it depends on the location of the equipment and the area of the ambient temperature system times. It can be changeable according to system designable. If refrigerant leaks, of course, the leak potential is very high. High operation pressures, vented during service, and small molecule size and pressure relief valves and multiple joints for the bigger system, leak potential is very high. And of course, hazard is high pressure during the operation and standstill. So we have to be good or detection equipment available. For the refrigerant leaks, we can use some spray, or we can use, of course, the gas detector for the suitable electronic ones, only dedicated for the CO2. And also there is some ultrasonic devices can be found. And refrigerant leaks also, if the machinery rooms has the charger than 25 kilograms, for instance, from the EN 378 norms, we have to be a ventilation system. Also, we have to put gas detection, a gas detector in the machinery rooms. Also in the EN norms, we can find all numbers. CO2 is heavier than the air. That's why the gas detector put in the bottom side of the machinery rooms, from the bottom 30 centimeters like this. There is also some rules, we can find it. And if the alarm start for the 0.5%, let's say the 5,000 ppm, that meaning is the concentration is increasing and we have to start for the ventilation. For the it's also when we come to the even, I think so, the information should be refrigerant prices just in Turkey according to cost of the refrigerant, what we see. And even for the, this one is the 1% CO2, and the other refrigerant prices, as you see, is higher than. So that meaning is for the, it's more and more feasible with the new system to install up the CO2 applications. So for the investment side, energy consumption side, and operation side, if we use the right conditions according to standard, we can provide very beneficial and the long life system with CO2. And market availability, now, of course, refrigerant can be used better. And of course, we can find some training. Knowledge is increasing. Components is more and more available. And right now is the all components can be found easily in anywhere, in normal conditions, not for COVID. And of course, tool and equipment is available. Thank you. This is what my slide today.
Thank you very much, Kıvanç. It was a very interesting presentation and also complete, even if the time available was not so much. We have some questions, and I would like to start, if you agree, with the most generic one from Hanan. How to choose the best CO2 system? Very generic.
Okay. It can be also, let's say, depend on the system design. And For instance, it's a cold room or it's a retailer store, low temperature, high temperature, maybe quick freezer. So what is the location? So we have to be careful about these details, and according to this we can choose. But for generally at the last term, of course, the retailer, for the multi-ejector being more popular, for the bigger capacity. For the smaller capacity also liquid ejector is enter our life. So if they can ask some question also, I can try to be more detailed after this training, because it's not, let's say, only one solution.
Of course, of course. Then we have half a question, half a comment by Ian. Did you say the high density of CO2 is decreasing pumping power or increasing pumping power? And what is the relative to these?
Decreasing, actually. It's up to also due to their volumetric efficiency. So the heat recover, or let's say throw up is very, very higher than the regular refrigerant or conventional system. That's why we need to be, let's say, the smaller size pipe or smaller volume of the heat exchangers, if I can understand correctly.
Yeah, I think the answer was also clear.
Yeah.
So the other questions that we have are either for flammables or generic for the debate. So I think it would be the best time for me to leave the floor to our Secretary General to conduct the final debate, and also ask Marino and the other speakers to come back live with their webcams for the final greetings. And I go back to translating. Thank you very much. Meanwhile, let me read the question for Marino. Brian asks, could hydrocarbons be used in domestic monoblock heat pumps as opposed to R32?
In domestic, yes, there are the regulations that can be used up to, if I remember well, 400 grams of refrigerants. Yeah. But it depends from the local regulation in the different countries.
Hello, everyone. So thank you so much, Kivanc and Marino, for the nice training. We have one generic question, which I think is very interesting, because it speaks about norms, about product normatives, about the norms 60335/2-89 about commercial refrigeration. And of course, there is also the -40 for heat pumps. It says, as they are not harmonized yet, what kind of certificate Real Alternatives does? What kind of certificate we do? We give with our project. Who wants to answer to this one? What we give? What
I think that I think, Marco, that the most proper answer can come from you or from Miriam, because the question is regarding which type of certification provide Real Alternatives. I think independently, I think also from this type of regulation.
Yes, the normatives.
Yeah, yeah.
So, Miriam.
Yeah, the certification for Real Alternatives at the moment is CPD. It's voluntary. We call professional development. This is not regulated at the moment. This qualification we offer is simply training and additional skills. So I know that Marco and your colleagues at ARIA, and I think all of us in different countries, are trying to encourage our legislators when they review the F-gas regulation to make this training a mandatory, and then we will comply with the other requirements. The standard, the norm that we discussed, I think was about or somebody mentioned, is a product standard. But in terms of training, there is no legal obligation on the training other than your normal duties as an employer to make sure people operate safely.
I think I can add only that it's good that we have a consistent training among the members, and we use the same manual, the same book, the training schemes, and some countries already implemented real alternatives in their national legislation, like Spain, as we said, and also we saw Armenia starting, and also more are probably starting as well. So it's also nice to have consistent training and certification around the globe. Yes. One question which is more a bit critical at the moment is about FAS, the restrictions. What will affect refrigeration from 2025? Hector is asking this question. It's a bit critical because it's something that we know is now at the top agenda above us. You know, we are not politicians, we are not policymakers, so it's above us, the FAS restriction. Am I right?
I think so, yes. And also FAS restriction should not be applied to essential use of the substances, as I think that refrigeration is an essential use, so should not involve the refrigerants.
Yes. Yeah. And I would like to keep to training and certification today and to content if it's possible. Yeah. So we have also a survey, I recall, so please fill the survey. I would like to have somebody from the audience. If they want to raise their hands, I'm happy to give them floor. I know I have the president of the African Association, Madi Sakande, who wants to say how useful was in Africa real alternatives. Can maybe my colleague Alberto give the floor to Madi Sakande from Burkina Faso, president of all the 50 Association of Refrigeration, 54, I think, if I'm right. Madi, I think you are connected.
Hello and good morning, everyone. Thank you so much for this special day of a real alternative. My best regard to Marco, to Didier, to Mr. Marino Bassi for a great training he shared here. As an African, we are happy and delighted to know that this kind of program is used in Europe. Unfortunately, we are in Africa experiencing unlikely event, dramatic event, because while we are changing the technology here in Europe to use flammable refrigerants, unfortunately, in Africa, there is not rules regarding the introduction of such technology, and we are experiencing some fire events, some explosion. Last year, we experienced 6 explosions in Nigeria. Unfortunately, 5 people lost their life there. Not more than 2 weeks ago, we experienced also in Zimbabwe an explosion event, died in son. Unfortunately, we lost also the son. So I think it's crucial and very important for Africa, of course, to talk about training or also about regulation, because Mr. Bassi, while talking about all this technology, talk about national regulation on this technology and these flammable refrigerants. And this is somewhere also to make a call to all the institutions which are now listing or participating to this important webinar, to know that, of course, Africa is at the end users of the technology. We can make a good technology here with local rules, but if we will bring this technology to some place where they don't even technicians have the tools to work with refrigerant, with flammable refrigerant, we, honestly speaking, all technicians in Africa who are going in the field will be unlikely a terrorist, because if you use a flammable refrigerant, you don't use scale the quantity of refrigerant you have to put in the system, of course, you will.
Yes, it will be important.
Explosion. So
also in
this
Africa.
is very important. We as African, we will have something to say on this matter sooner because we are green. We want to save the world together, but we have to remember also that all this new technology is sharing around the world. So we have to pay attention about this matter while we make a new rule for our country, for our area. The world is now a small village that have to think global. Thank you so much.
Thank you, Madi. Thank you for your evidence. We have been together in Burkina Faso, Togo, and you're going in a couple of weeks in Madagascar doing training following real alternative schemes, right?
Yes, you're right, Marco. Of course, unfortunately, this training is made for 15 or 20 people, and 20 or people cannot be all the technicians in the country. So we need to spread more work. We need to make more training. Of course,
we have to share our experience.
Only from UNIDO or from other institutional area. It must be also in the local level, so that we need from the partners of African countries to raise the awareness about this matter. Because we talk about efficiency, we talk about climate change, but we never talk about fires. This is very, very important. We have to talk about, this is a big issue, because the question we are raising around right now is to die today or to die on 2 centuries.
No, it's not like that.
Several questions. We cannot live for 2 centuries, so that means we are able to die now with fire, explosion, with these technologies. We have,
of course, and we focus a lot on safety. Our project is about safety.
I see a lot of projects, a lot of technology manufacturer making advertising, making, of course, a report to say about the efficiency, to save about energy save, to save about greenhouse gases saving, to talk about everything except explosion.
No, we talk about it. Safety is important. We always take care. We always take care about safety.
I know, Marco, but talk about the technology.
I know.
I talk about technology.
Sorry,
this is the reality. Thank you so much for your time.
My pleasure, Madi, always. Any more? We want to share your comments, your feedbacks. Speakers, please. I can see we have still 200 people online. I can still see few hands over. Can I give you the floor? Hands over. Are you ready to speak? I give it to you. Share your just 5 more minutes because we are on time perfectly. So I want to give 5 more minutes if possible. So I have 2 persons here that raise their hands. Do you want to say anything? Nebolo Parastus, do you want to say anything? You raised your hands for some reasons. And Nobuyuki Takeya, do you say something? Nebolo.
Yes, good day.
Where are you from, Nebolo?
I'm from Namibia.
Namibia.
Yes.
Please.
So I really appreciate this webinar today. It's really informative, and it really make me to really believe that refrigeration and air conditioning, we become also a global village really, and we have then to consider and also to agree that we are from different corners of the world with different temperatures. Like Namibia can be hot, and it can also be cold. We receive different equipment with features that are not necessary here. I don't know how do we do this, and if you are a qualified refrigeration technician, it's only when you can figure out that no, this was made maybe to superheat or to subcool. So, but a layperson or a person that just learned refrigeration from us qualified people might not identify why that components. What I want to say is, to be honest, we could be fast with technology. I just want to concur with Madi. we could be fast with technology, but we must also take cognizance of that those equipments end up in the hands of people at the different corner of the world where the temperature differ, and also the training must really be shared and the technology must really be shared, so that we don't leave each other behind.
We are here for that reason. We are here for that reason, to share the knowledge and to give it to you, this knowledge.
And I'm also a president of my HVAC in Namibia. Namibia HVAC, I'm the president of the association. But yes, definitely, if you guys can really, it's always easy to maybe gather, but through our president, Masamadi, they just left now.
Yes, of course. We are in strict contact with Madi for Africa, of course. Yes. Me as president of AREA and Madi as president of UFRIARC. Thank you, Nepal.
All right.
Thank you so much, Nepal. Takeya, did you raise your hand? Do you want to say a few words, Takeya? Maybe you're from Japan, or am I mistaken? Takeya, can you hear us?
This is Takeya speaking. Thank you for the webinar. I'm not raising the hand, but it's a very informative, and I'm
very good.
in charge.
Where are you from, Takeya?
Yeah, I'm from Japan, but I was formerly transferred to France.
All right. Okay. And, thank you, Takeya. Sorry, I thought you raised your hands. Thank you, Takeya.
I'm in charge of HBSC business, still in charge of HBSC and our business in Europe.
Okay, so, thank you so much. So, if do you is anybody need has anything else to say? Questions? I think we can finish here, but few more things, of course. The poll, the survey, we close it now. I think you can see the results. So, are you currently using alternative refrigerants? 63 says yes. 63% says yes. 136 people answered. Were you aware of real alternatives? 56% says yes. Are you in favor of mandatory certification? 76 says yes. This is always a very high percentage. Always when we do this kind of survey, always is very high who wants to have mandatory certification similar to fluorinated gases. So 76% of people want mandatory certification. Do you think natural refrigerant will take over synthetic refrigerants in the near future? 32% says yes now. 49%, so half of our audience, says I think, but not in the near future. 13 says I have doubts. 7 says not at all. So I have to be honest, the audience, which probably is more linked to alternative natural refrigerants, says that it's very likely that we are going to move everything on natural refrigerants. But we have to be honest, but the audience probably is more related to natural refrigerants, our audience today, of course. Yeah. Do you think you will use the real alternative training provider? 50% says yes, which is very, is very positive. I'm very happy about that. This was the aim of our project, and our webinar, of course, that you are coming to do training because we need training, and also the revision of the gas regulation. I'm sure we'll push on the training side. I think there is no doubt on that. 32% says yes, but not in the near future. 50% says no, and 4% says no. Any comments about this this survey? Do you have any comments, my dear colleagues? Okay, we are done. So my last word is to thank you, all the 184 participants, all the 10 speakers we had today, all the translators, the interpreters. They did a great job. It was not easy to do 6 languages translated at the same times for all our technicians. So I think everyone did a great job. So Thank you so much, everyone. You did a great job. And thank you to my team, of course. Bye-bye. Maybe you can you want to turn on your Microsoft and say bye-bye. And everyone maybe want to go. Maybe someone want to come.
Thank you. Thank you,
everyone.
Congratulations.
Thank you, Marco, for all. Thank you very much.
Thank you, everyone.
Bye.